All right, let's turn to the final problem set in decision analysis, and this one requires again base theory. So the context is that you are suing Arctic Slurpees after your tongue froze for 10 minutes to the straw, causing you severe frostbite. You are certain to win the lawsuit, but you do not know whether you win high, medium, or low. Your expected compensation payment for winning high, medium, and low are $40,000, $10,000, and $2,500 respectively. Your probabilities of winning high, medium, and low are 0.4, 0.3, and 0.3 respectively. Arctic Slurpee offers you to settle at $22,500. Below graph summarizes your decision. Okay, so I think the good thing is that I can copy now this one into Word, and then we don't have to always go back and forth. Maybe that was a bad idea, so let's keep it like this. Or actually, let's save it quickly as a picture, then I can. Yeah. So assume risk neutrality. Under the assumption of risk neutrality, what is the expected payoff from litigation? Okay, so now the expected payoff from litigation is $0.4 times 40,000 plus 0.3 times 10,000 plus 0.3 times 2,500 Okay, so this is 16,000 plus 3,000, so 16 plus 3,000, so that's 19,000 plus 750, so that is 19,750. Which is obviously less than the settlement offer. So you would settle. Under the assumptions of risk neutrality, what should you do? Litigate, accept the settlement offer, and of course, if you just have seen, you would accept the settlement offer. Under the assumption of risk neutrality, what would be the value of perfect information? Okay, so now let's move to the value of perfect information. So again, I always like to say, okay, God has perfect information. So the expected value of perfect information would be that we approach God with a probability of 0.4, thinking that we will win high. And now God tells us you will win high. So what do? Okay, you litigate. So then you get the 40,000. But you also approach God with a probability of 0.3 that you win medium. But if God tells you win medium, then you settle. And likewise, if God told you that you win low, of course you also settle. So the expected value of perfect information is, here's my calculator here, 0.4 times 40,000 plus 0.3, actually I can do 0.6 times 22,500 So the expected value of perfect information is 29,500. Under the assumption of perfect information, what will you do? Well, litigate, settle, litigate if perfect information is high, otherwise you would settle. That's correct. And how much are you willing to pay for the perfect information? Well, the willingness to pay for it is what you have for sure. That is 20,500. And the difference to what you get from perfect information. So it is EVPI minus the certainty value. So that is 29,500 minus 22,500, so that's 7,000. Okay, so now we have a different scenario. Consider the following decision tree. Okay, so for what probability P would you litigate? So for what probability of P would you litigate? So now what we need to make sure is we need to identify that the expected value from litigation is higher than the settlement offer. So the condition that needs to be met is that the expected value from litigation needs to exceed 22,500. Okay, so that means we need to solve under which condition is 40,000 times P plus 0.3 times 10,000. I feel there's like a couple of zeros missing. Okay, so 40,000 times P plus 0.3 times 10,000, which is of course 3,000, plus 0.7 minus P times 2,500. That needs to be greater than 22,500. Okay, so let's solve 40,000 P plus 3,000 plus 0.7 times 2,050. So that is 7, what is that? Probably 750, but let's double check. 0.7 times 2,500, yeah, 750, so plus 1,750 minus 2,500 P, and that needs to be greater than 22,500. Okay, so now we can collect some terms. So we have here 2,500 P that I cannot subtract, so then that leaves me with 37,500 P plus 4,750, which is greater than 22,500. Okay, so now we have to subtract the 4,750, and then we are left with 37,500 P needs to be greater than 22,500, so that is 17,500, 17,750. When I subtract it and then we divide by 37,500, and then we get, as long as P is greater than 17,750 over 37,500. Okay, so 17,750 divided by 37,500. Okay, I get 7 over 150, or 0.4733. So that is 0.4733, which is C, 47 1/3. Okay, that was a little bit of sensitivity analysis. So, but now let's move to the value of imperfect information. Let's clean up this sheet. So, okay. So assume you could consult a law firm that looks into your case and tell you whether they think you have a strong or a weak case. Consulting versus not consulting eventually presents you with a new decision tree. Subjectively, you believe that the law firm evaluates your situation as follows. Okay. So they think, if they somehow look at your case and they think you will win high, they come up with a verdict of you having a strong case with 0.9. If they think it is medium, it's still 0.5, and if it's low, it's 0.1. Okay, so those are subjective probabilities. So now if we take a look at your decision tree from consulting. So you can either consult. So if you consult the law firm, there is a probability that they come back to you and tell you that you have either a strong or a weak case. Okay, so this can happen. So they either will tell you have a strong case, or you have a weak case. Well, then, if they come back to you and they tell you they have a strong case, what you need to do is you need to decide, shall I litigate? Or shall I settle? Okay, and we know that when you settle, you make 22,500. But if you litigate, and I need more space here. But when you litigate, you know that you can win high. That's again decided by nature. So you can then either win high or medium or low. Okay, and again, if you win high, you will make $40,000. 10 or 2,500. Well, the same happens if the consulting company comes back to you and tells you that you have a weak case. Then you have to decide, shall I litigate? And then, of course, the probability is again that you win high. Or you win medium. Or you win low. And again, if you win high, you'll get 40,000. I got to squeeze that in a little bit. 10,000 or 2,500. Okay, so what you need to know, of course, is what's the probability that you win strong. So what is this probability? And likewise, you need to know what's the probability that you win weak. So that is what we need to find out. Well, now we have here conditional probabilities. So ultimately what you want to know is what's the probability that I win high given that the law firm tells me I have a strong case. So this is written as the probability of high given that you have a strong case. So we need to know this, and then likewise, what's the probability that we win medium? Given that we have a strong case. And lastly, what's the probability that we win low? Or that we come out low? Given that they think I have a strong case. Likewise here, we want to know, well, I forgot to actually complete, and of course we can also settle here. $22,500. But here we want to know, if we get the weak case and we litigate, then we want to know what's the probability that we win high given that we have a weak case. Likewise, what's the probability that we win medium when we have a weak case? And what's the probability? So obviously what happens is that the probability, you will think that you will win low with now a higher probability if you are told you have a weak case. So those are the things that you ultimately want to know. And likewise, so the final thing that we need to add is, if you do not consult, we know that you will not litigate and you accept the settlement offer. So not consult. That's also the 22,500. So ultimately what you are interested in is the probability that you win high if they tell you you have a strong case. So before we answer these questions, let's just work a little bit on those things here. So what's important for you to know is what's the probability that you win high given that you have a strong case. And this is now where Bayes' theory comes into play. So using Bayes' theorem, we can rewrite that term as the probability of high times the probability of strong given high divided by the probability of strong. Okay, so that is the first one that you want to know. And then you want to know what's the probability that I win medium. I just called it now medium, given that you have a strong case. And using Bayes' theorem, that can be written as the probability that you win medium times the probability that you win strong given that they think it is medium over the probability of strong. Then you want to know what's the probability that you win low when you are told that you have a strong case. And that's the probability of low times the probability of strong given low. Over the probability of strong. Okay, let's just stop here. So now we have now taken a look at basically these conditional probabilities after you get a verdict of that you have a strong case. So, okay. So as we can see is we already know what's in the numerator because we know that with the help of our subjective probability. And just like as we earlier, we approached God with the probability that we win high. Okay, so that is the 0.4. So now we would say 0.4 times. Okay, so what's the probability of strong high? That's your subjective probability. You see strong high, this is the 0.9. So this is 0.9. And this sums up to, in the numerator, to 0.36. So this is 0.36. Okay, let's worry about the probability that you have a strong case later. So what's the probability that you get a medium? Initially, so you approach the consulting company with an initial probability that you win medium with 0.3. But now you think that given that the consulting, the law firm thinks that you win medium, the probability that they recommend you have a strong case is 0.5. So, okay, I need to go up here a little bit. slide. Okay. Yeah, let's just continue here. So he said the probability low, strong, that is the probability of low. It was 0.3 times the probability of strong given low over the probability of strong. Okay, so again, in the numerator, we know we approach the law firm with the probability that we will low with 0.3. But now we think that they will recommend that we have a strong case when they actually look at our case and think we win low, that's only 0.1. So that is equal to 0.03. And again, we don't worry about the strong for now, but we do that next. Okay. So what we know is that there is a probability of high given strong, that's 0.36. So this is how we can come out with strong. And let me go quickly here. And we could come out with a probability of 0.15 with strong. So now we are already at 51. And the last one that we did, which is on the next slide, was 0.03. Okay. So now we know that the total probability of coming out with a strong case is we will come out here with a strong case of 0.36 plus 0.50 plus 0.3. So if you sum that up, that is now 0.54. So those are all the combinations where we, where it's possible that they recommend a strong case. So 0.36 plus 0.15, so that's 0.54. So now we can add here 0.54. Okay, so we divide everything by 0.54. Then of course the weak case, that will be 0.46. But we do that in a second. So let's add this one. So we divide here by 0.54 and here by 0.54 and here by 0.54. So we can find the common denominator, which I think is 18. So this here would be 36 over 54. If we divide by 18, we can't. So let's divide by 3, and then we get here 12 over 18. And this will be 5 over 18. And the last one will be 1 over 18. Okay, so now we have calculated those conditional probabilities. And you see, initially you thought that the probability that you win the case high, that was 0.4. But now, if you are being told that you have a strong case, that probability goes up to 12 over 18, or 2/3. So now we can append those probabilities here. So here we have 12 over 18. So this is 12 over 18. This one is 5 over 18. And the last one is 1 over 18. Okay, so now we still need these probabilities here. And okay, so let me put that in a new slide. And actually, let's quickly delete this here. Okay, so now we use again Bayes' theorem. We need high given week, medium week, low given week. Okay, so we want to know what's the probability that we win high given week. And this is by Bayes' theorem, the probability of high times the probability of weak given high over the probability of weak then the probability of medium given weak, that's the probability of medium, times the probability of weak given medium over the probability of weak and the last one is the probability of low, given that the law firm tells us you have a weak case, so that probably goes up then. So that's the probability of low times the probability of weak given low over the probability of weak. Okay, so the first part, probability high, medium, and low, we already know this was the 0.4 and the 0.3. Okay, but what's the probability that they tell us, that you have a weak case, given that they actually think it is high? Well, that is of course the complement to the probability of strong given high, right? So that is then 0.1. So this is 0.1. So that's just a complement to this one. Okay, so now if we multiply that through, we get 0.04. In other words, your probability that you have that you will win high, given that the law firm tells you that you have a weak case, is now down to 4%. Okay, again, we worry about the probability of weak later. So the probability that you have a weak case given medium, of course, that's a complement. That's again 0.5. So that is equal to 0.15. And the last one, the probability of having a weak case, given that they think we will win low, it's pretty high, it's 0.9. So this is 0.27. Okay, so those are all the combinations where we think, well, we could come out with a weak case. And that's 4% plus 15%, 19%, plus 27, so that's 46%. So the probability of weak is indeed 0.46. Okay, so now we can divide everything by 0.46. Okay, so now we can complement or complete our decision tree. So we add this here. So we said this was 4 over 46. And then that was 15 over 46. And the last one was 27 over 46. Okay, so now we have our decision tree that we can work with. And maybe I just put it a little bit here. Okay, so now let's see some of the questions. Okay, I hope you still can read it. Okay, so now question 7. Assume you could consult a law firm. Okay, the probability of strong given high is 0.9, strong given medium is 0.5, and strong given low. So that implies that weak given high, weak given medium, and weak given low, those are the complements. So that's 0.1, 0.5, and 0.9. So the correct answer is A. Which of the following is true? So the probability of medium given weak, how can that be written? Okay, we did that right now, but I probably can't find it anymore. So, but using Bayes' theorem, the probability of medium given weak, I'll not just write it now like this, a little bit shorter. Probability of medium given weak, that is equal to the probability of medium times the probability of weak given medium over the probability of medium. Okay, that is Bayes' theorem, but of course we can also write it as the probability of medium, and so that's the intersection sign, and weak over the probability of medium. So A is correct, right? It's the intersection of medium and weak over the probability of weak. And B is also correct because that is basically Bayes' theorem, so the correct answer is A and B. So what's the probability of high times the probability of strong given high? Okay, so the probability of high, so this is this term here, right? This is the probability of high times the probability of strong given high over the probability of strong. So in this case, this was to be, so we calculated that as the 0.4, that was the probability of high, times the probability of strong given high, that was the 0.9. So that is the 0.36. So that's here. Then the probability of medium times the probability of strong times medium. I'm going to remember that was the 0.3 times the 0.5. That was the 0.15. Probability of low times the probability of strong given low. So that was the 0.3 times the 0.01, 0.003. And then if we sum them up, we get the probability of strong, and that one was 54. Okay, so the probability of high times the probability of weak given high. So now we are somewhere down here. Probability of high times the probability of weak given high, that's the numerator of this term that you see on the top now. That was 0.04. Probability of medium times the probability of weak given medium, that's the numerator of the second equation that you can see, that was 0.15. Probability of low times the probability of weak given low, that's the numerator of the third equation, that's 0.27. So the probability of weak is 0.46. Okay, so now what's the probability of high given strong? So now we have already put that into our decision tree, and we know the probability of high given strong. We already calculated as 12 over 18. Medium given strong, that was 5 over 18. And actually that should be low given strong. But that is 1 over 18. Then high given weak, 4 over 46. Medium given weak, 15 over 46. And low given weak, 27 over 46. Okay, so now we calculated all the probabilities, and now question 23 is about the expected payoff of litigation. So the expected payoff of litigation if you have a strong case. Okay, so if you have a strong case, we will write expected payoff litigation given a strong case. So that means we have to evaluate 40,000 with probability 12 over 18. 40,000 times 12 over 18 plus 10,000 with probability 5 over 18 plus 2,500 with probability 1 over 18. Okay, so now let me use my calculator. Okay, so now we get 40,000, 1, 2, 3, times 12 over 18 plus 5 over 18 times 10,000 plus 1 over 18 times 2,500 equals, so I got 29,583. So 29,583, actually 0.333583. Okay, so yeah, that is then answer B. So now what is our decision? Well, if they tell us we have a strong case, then we can eliminate the settle. So that's gone, because then we get a strong case, we want to litigate. Okay, so what's your best strategy if the law firm tells you have a strong case? Well, then we litigate. Okay, what is the expected payoff if you litigate given that you have a weak case? Okay, so now the expected payoff would be, okay, I hope I can squeeze it in here. Expected payoff, litigate, weak. Okay, that is 40,000 with probability 446 times 40,000 plus 15 over 46 times 10,000 plus 27 over 46. I need to squeeze it in here. 27 over 46 times 2,500. Okay, so that is equal to, okay, let's use my calculator. Okay, 4 over 46 times 40,000 plus 15 over 46 times 10,000 plus 27 over 46 times 2,500 . So now I get 8,206.5. So if we round it, it's 8,207. So that is 8,207. But it doesn't really matter because it's far below the settlement. So in this case, if we are being told that we have a weak case, we eliminate the litigation and we settle. But nevertheless, the correct answer is 8,207. So what's your best strategy if, there's an if missing, if the law firm tells you that you have a weak case, and then you settle? What's your expected payoff from consulting the law firm? Okay, so now if we consult the law firm, let me erase here maybe some things. So the expected payoff from consulting the law firm is consult. So we know we have a strong case with probability 0.54. And then we expect to make 29,583. And we expect with a probability of 0.46, I'm going to make here 0.46, we get the 22,500. Okay, so the expected payoff is 0.54 times 29,583 plus 0.46 times 22,500, and then I get 26,324.8, but if you round it, it's 26,325. So that would be D. So what is the willingness to pay for that? Well, we know we make 22,500 for sure. So the willingness to pay is essentially the expected value from imperfect information, which is the 26,325, minus what we have for sure, which is the 22,500. Okay, so what is this? So this is 26,325 minus 22,500. 3,825. So that is 3,825. And if you remember, if we had perfect information, our willingness to pay would have been much higher. Okay, so that's it. And yeah, I know it's a little bit complicated. That took a little bit longer, but yeah, this is how you solve a decision analysis problem. And that was also the last exercise, the decision analysis. So yeah, I hope you found it interesting and learned a lot. So.